The list of words given here and there are list of words given here, right? This is a grid that has been arranged with a lot of letters. Now if you look at it, B-A-R-K, bark is here, park is I think P-A-R probably, right? Park, M-E-N is there, lot is there, L-O-T, cement is there, I think C-E-M-E-N-T, right? So you have to find a particular word is present in the grid by moving down right across. If this is a question that is given to you, how do you solve it, right? This backtracking can help you solve this particular problem. So let's look at the summary here. So these are the words that we discussed earlier, like the way we said, bark is there. That's what you see in the answer, right? Park is not there because you can move only down and right. Cement is there, lot is there, and per I think is there. So if you see all the words except for park, all the other words we are able to find by moving down and right. It is, if you look at it, a maze problem that we saw earlier, but now we are applying to string. Now let's see how to solve this problem. I'll show it in Java and Python so it's easier for you to understand. We'll follow the same template that we saw in the earlier videos as well. So it'll be very easy for you to follow and solve this particular problem. You can pause here and then think about how do you solve it, right? How do you build a word incrementally, right? You can think about it and then probably you can continue the video, right? Pause here if you want to think and solve on your own, and then you can come back and look at the solution. So let's look at the Java code first. This is the number of rows and columns, which is a global. This is the grid, which was kind of like the crossword that was given as input, the solution matrix, and then we are having the target, right? So this is the target thing which will get updated every time. So now in the main program, we are getting the row and column for the grid, and then we are getting the actual grid, right? We are getting the grid from the user. So this is where the grid is obtained. So you have the crossword like thing that we have obtained. Then you are asking for the number of words that we have to search in the grid. And for each of the words, it's stored in words of I, right? So this is the initial input. And now this is where the backtracking code is going to start. I mean, actually in the main function, this is the calling place for the backtracking function. And after that, we'll see the backtracking. So we are taking one word at a time. So target is a global variable, which will be set to that particular word. Say for example, first we are searching for the first word MEN, right? So then that will be the word that will be set here. And solution will be initially set to all zeros, right? We already know how it is done. Now we are saying that this, which is going to say that whether we have found it or not. So we are taking each and every word, right? We are going each and every letter as the starting letter in the grid. And if that starting letter matches with the starting letter of the target, only then we call the backtrack, because there is unnecessarily we don't have to call with every letter, right? For example, if we have a grid, we'll go through each and every element in the grid. So I'll show the grid. So if you're searching for bark, first it will start with this B and this word in bark is matching. So it will start from here, right? But let's take if it is MEN, right? It will check this first word. First letter B, is it matching with this M? No. It will move to the second one. Here it will check whether A is going with M. So it will skip all these letters and then it will come here. M and M are matching, so it will call the backtrack. But here you will not find the answer because going down right or this way you don't have the answer, right? So it will proceed ahead and finally it will come here. You have the M matching. Again it will call the backtrack, so then you will find the MEN in this particular case, right? So this is what is happening there in the main for. So this is the code that I explained. So only if the first letter is matching, it will call the backtrack function for that particular word. So now the backtrack is a very familiar code that you usually see, right? So here we are having the goal, that is there is a current, right? Initially the current is going to be null, right? And the grid of I comma j is passed. So whichever be the grid starting letter, that is getting passed here. So if it is equal to the target, right? If the current is equal to the target, it will return. So this is the goal check. We are first checking the goal. Second, we are checking if I and j are valid moves. This is how we do for the maze and other programs as well. Third is, this is to avoid the infinite recursion. We have already again seen it in the maze 2 video, right? In that we saw this. So if solution of r comma c equal to 1 means already we have visited that position in this path. So we should not be going into an infinite recursion. To avoid that, we check this particular condition. So if all these three conditions are checked, then we set solution of r comma c is 1 to say that we'll assume that this particular character is going to be part of the solution, right? And here, right, very interesting part. This is the first time you'll be seeing this. This is not something you would have seen in the maze. Current, which is the empty string, you're adding that grid letter wherever we are. So I comma j, it's a valid portion. We are adding that. So if it is MEN, right, M will be added to current. And you're again calling backtrack, right? It is 2 directions, not 4 directions. So you'll backtrack for the next row and same column, and you are passing the current. If in that path you find the answer, you return true. Otherwise, you call with r comma c plus 1, that is the same row, next column, right? In this particular case, E is in this particular question. So this is what will return true, right? So it will backtrack with this, right? Let's assume that after going through this, it has not found the solution, right? Then what happens is this current, we'll remove the current character, right? So substring of current length minus 1. That means this last character that we added, we are removing because it is not part of the solution, and we set solution of r comma z as 0. So if you look at it, this is the new thing that you're learning in this particular code compared to the earlier maze code that we have seen, right? So if you look at it, we are adding a character, we are passing it to the string. So that string is dynamically getting built here with all possible combinations. So first the string would have the M, second it will start with M and E, third it will start with MEN, right? So then it will return true. So if you look at it, all the possible combinations are getting generated through this particular flow. And if it is not able to find, like the way you're setting the solution of r comma z to 0, you're removing that particular character from the current string. So this is the important thing that we'll have to find from this. So unique thing that we are learning out of this particular exercises, how do you add a character? This can be even done for numbers, right? You can increment the current sum, you can subtract the sum here. That way that particular thing is considered, and if it is not there, you remove it from that solution, right? This is the same thing that is happening here. So let's give a particular input and check. So here we have an input. This is the input matrix. We are considering a 5,5 grid, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, right? So these are the 25 alphabets which I have given in the grid. And I'm giving 3 strings to search: KLM, PQR, WXY, and START. So KLM is there, right? KLM is a straightforward one. KLM is there. And PQR, WXY is there. PQR, WXY. We see that as well. That should also return a true. Start, ST, and then AS here. So we don't have a path to start, right? So these two should return true. This should return false, right? Let's run it and check. Like we expected, these two are returning true and this one is returning false, right? This is how it works. And I'll also show you the Python code for this. Very similar one, not much of a difference. The logic remains the same, just that it is a Python code instead of a Java code. So if there are Python developers, you can check this code. This is a Python solution for the same thing, right? So if we need all the 4 directions, we can do this. If we just need the 2 directions, we can knock off these 2, right? So it will work. So we can knock off these 2. Like Java, this remains the same code for Python, right? So here is the main code where we are checking each and every path. And then we are moving forward, right? This is the Python code. Logic remains the same. Whatever we discuss in Java, the same thing applies for Python.